Hi everyone, and welcome to our video on finding an equation that represents these curves, which are either secant or cosecant curves. And it really is up to us, depending on how easy we want to make it. So sometimes it's one is easier than the other. Sometimes it often doesn't matter. Okay, so it's going to be up to us. All right, but whenever we have these, we do see instantly they match the secant or cosecant style. Well, similar to our ones that we were graphing, like up here. So like when we had secant, we went instantly to cosine. Um, I want to also do that when I have a sketch. I want to see either cosine or sine in these problems. So in the blue, I'm going to take the same strategy and say, well, here's a peak, and here's a peak. That's where they should have shared points. Okay, and we can start to connect them. And we can see what that looks like that. And mine might be a little off with the drawing, okay, because it's hard to see what the asymptotes currently are. So they didn't put them in, but we might not really need them. Okay, so based on this in the blue, well, it starts up high. This looks like a generic cosine curve. Let's just say cosine, because we know here's the most basic cosine curve. It starts up high and does that. Okay, so it looks like a cosine curve, but not the most basic, but it does, we see, oh, there's no reflection, and we could see the amplitude, we could see the period. Eventually, so because that in the blue is cosine, it means the one that was given to us is secant. So on this first graph, it looks like it's easiest to do a non-shifted cosine curve. And then we'll just get all of our information. Okay, so in the purple, I can say right here, is 2. Our scale is 1, so 1, 2. Yep, looks good. Okay, so our A is 2. And then our period, let's get that in green. So our period goes from here to here. Okay, well, really there to there. Let me bold that there. So that's the period. And we can see, oh, it went from 0 to 1. Or you can think the bigger number minus the smaller number. So the period is 1. But with the period, we know that it comes with the b value if we change our equation. So remember, the period is 2 pi over b. And here they are saying the period is 1. So we will just change that to be 1 equals 2 pi over b. And then let's multiply both sides by b. So that way we get b is 2 pi. Okay, so we've got our b value now as well. So we have our a, we have our b. We said in the blue is cosine. So that means in the black ink, it's secant. And we can instantly start to draw or write in our equation. So all of the same information for cosine matches the secant information. So the a and the b, we know it's not shifted. So that means, well, now let's just plug those in. I have a, I have b. So it looks like we should just do y equals 2 secant of 2 pi x. There we go. Okay, that's it. And we could double check again. You could always double check. So for instance, we have a point, 0.5, and -2. So if I plug 0.5 in, it'd be 2 pi times 0.5. Simplifying that would be y equals 2 secant of pi. Secant of pi is the same as cosine of pi. They're both -1. And so yeah, it matches. Okay, so we could double check these pretty quick. All right, let's see this next one. Okay, so same as before. In the blue, I'm just going to connect peaks. Okay, so there's some. We also do know because of the asymptotes, they did put them here. That's where a sine or cosine curve would cross the x-axis. Okay, so I've got lots of information this time. Okay, like that. Okay, so this is a sine or cosine curve. Now, it depends on where we want to start it for our sine or cosine. So for instance, so I'm going to erase this in a second, but I'm going to highlight from here to here. So this highlight I am going to erase in just a second, but I do want to point out this highlighted would be cosine very similar to the last problem. Okay, so the reason I want to erase it is let's do a different function. Let's get sine involved, because sometimes so this had lots of information. Sometimes they don't give you lots of information and you might be forced. So what I'm going to focus on, I'm going to highlight it in red. All I want is to highlight one period or draw one period, and I'm starting over here at negative 3 pi halves, and then I'm drawing it like that. So sometimes they don't give us everything. I'm pretending they're giving us restricted information. So just the red is kind of my focus now. So this in the red is one full period of a sine graph. Okay, so this is sine in the red, because we know the most basic sine function starts on the axis and goes like that. So we can see, oh, it should be reflected, because let's get that one too. The most basic reflected sine graph would have been that. Okay, so we can start to see, oh yeah, our a value is going to be negative, and it is definitely shifted, and then we'll have to find our b value too. Okay, so let's start marking these things. Okay, so in the purple, let's do our amplitude. Okay, so it looks like whichever way I'm looking at it, so either this way or this way, those look the same. So that means there's no vertical shift. It looks like the scale is 1. So on this problem, the A is also, well, the amplitude of A is 2. However, we said it was reflected, so we know we should just make the A negative 2. Okay, so there's our A value. Okay, so I marked it. There's the amplitudes. And then let's get our phase shift. So the phase shift is quick. I'm going to do that in, what color have I not used it? Let's just do it in the black ink. Okay, so usually sine starts at 0, 0. Here's where 0, 0 would have been, but it got moved over here. Okay, so that's our phase shift. So our phase shift is negative 3 pi halves. Okay, so it went left 3 pi halves. And then the next thing we need is the period. Okay, so that let's do in green. Okay, so I have it marked in the red. From here to there is the period, because we can see, oh yeah, that matches our sine curves. That's where it starts to repeat itself. And so let's set it up. We know the period is whatever the bigger value is, so 5 pi halves, minus whatever the smaller value is, which is negative 3 pi halves. And so this really becomes addition. It is 8 pi halves, which gives us the period is 4 pi. Okay, however, just like the last problem, once we have the period, I mean, that's great, but what we really need is b. So we're going to solve for b here, because we know the period is 2 pi over b. So I'm going to do it like this. Our period is 2 pi over b, and then let's change the p to be 4 pi. Okay, and then when we cross multiply, so the b and the 1 cross multiply, let me put that rest of the work right here. We've got 4 pi b equals 2 pi, and then we will divide by 4 pi. So b is, the pi's cancel, 2 over 4 is 1/2. There we go. Okay, so now we've got all of our letters. Now let's set up our equation and then just plug in those letters into the equation. Okay, so we said in the red is sine, which means, I didn't mark this yet, which means the given graph is cosecant. Okay, so all of the letters still match the same. We just need to write it as y equals a cosecant, and then bracket b x minus c. So I'm just doing a, b's, and c's. Okay, again, those letters can change. Like I didn't use c, but this is c in this scenario. And then we'll just plug them all in. Okay, so we have y equals -2 cosecant bracket 1/2 parentheses x. Now the phase shift is negative, so that means change the sign in here to be plus 3 pi halves, like that. Okay, so that is our curve, or at least a curve for this, or our function, a function for this curve. So you can have different answers to this. Okay, so that would be it. Let's highlight one more time. So I'm going to go back to the highlight and say, what if I had started with that? I just did that. Well, the A information and the B information would be similar, just the phase shift is going to change. Okay, so if you want to try this, so another one would have been, so that's in the highlighted is a cosine curve that's not reflected. So that means it should be +2. And then we do want secant eventually. The B is the same. It does have the same period. And then the shift, though, is different. It went to the left 5 pi halves. So that should be plus 5 pi halves instead. Okay, so this also works. So in case they say, oh, we wanted secant instead of cosecant, there we go. Or vice versa, okay? So sometimes they get picky, but if they're not picky, it's up to you, and try to make it as easy as you can. Okay, so that's it. There's our secants and cosecants, which really, again, are sines and cosines. Okay, so break it down that way. Okay, I hope you enjoyed them. If you do have any questions, please let me know, and thanks for watching.